Hello, this is Mrs. Boots, and welcome to our lesson on end behaviors. You may be wondering what this is, and this is simply the ability to either look at the graph and just from a quick glance figure out basically what kind of equation you're looking at, or look at the equation and figure out basically what the graph looks like. So it's a little trick so that you can, it's kind of like a common sense rule. So when you plug it in your calculator, when you're working out on your paper, you can look at the original problem and say, did I do that one right? Yep, I got it right because of this common sense rule over here. So that's all end behavior is. It's just a quick check, common sense rule so that you can figure out whether or not you've got it right or whether or not you plugged it into your calculator correctly. Okay, so you've got 4 graphs on your paper. These are obviously not to scale. There is no scale labeled, but you've got 4 graphs. And these 4 graphs, what we're looking at is where do the arrows go? I don't care about how many curves are in the middle at this point, just where do the arrows go? So I notice that for the very top one, both arrows go up, right? They both go up. On the negative infinity side, it goes up. On the positive infinity side, it goes up. So we don't write up because up can mean any number of things. What we write is that y goes to positive infinity. So they're both going up. Y is going to positive infinity. All right? Now look at the second graph right underneath it. It's got a lot more curves, but where are the arrows pointed? Down. They're both pointing down. So that means as x goes to negative infinity, so I'm on the left side of my graph, y is going to negative infinity. Okay? On the right side of my graph, that's where our Buzz Lightyear lives. As x goes to positive infinity, unfortunately, Buzz is having a bad day. Y is going to negative infinity, right? Okay, so notice with the first 2 examples, the arrows end up going in the same direction. So they're either both up or both down. So we're going to look at what kind of equation would make them both go up or both go down. Okay? So now let's look at the third one. On the negative side, it's going to negative infinity. So as x is on the left, or the negative infinity side, y goes down, or to negative infinity. On the right, as x goes to positive infinity, what does y do? Y also goes to positive infinity. So this graph, they go in opposite directions. Opposite directions. Not the same, right? These go in the same direction. Both in the same direction. Now I have the ends in opposite directions. We're going to look at that. Last graph. Is it same direction or opposite direction? It's opposite. So it's very similar to the one right above it. Only this time, on the negative infinity side, y is going up. So it's going to positive infinity. It's the exact opposite direction of the graph above it. And on the positive infinity side, y is going down to negative infinity. Okay? So this is where you might want to use a graphing calculator, and you can look up the graph. So you could actually plug into y equals 3x squared. Okay? I'm not going to plug it in and hold up the calculator because you won't be able to read it anyway. Not from here. So you can do it on your own. Plug in 3x squared. But we can do this part, right? We know what the degree is. It's 2. We know it's a quadratic. Oh, wait. We studied quadratics in Algebra 1. What did the quadratic look like? Do you remember? Oh, yeah, it's that U shape. So of these graphs over here, which one would be the quadratic? Yeah, the first one. The first one would be the quadratic, okay? So because we already know a little bit here, okay, the quadratic, we know looks like a U shape. Do both ends go in the same direction? Yes, they do, okay? They do. We're going to use that. So, follow-on question. What kind of number is 2? Is it even or odd? I know. It's elementary school, Mrs. Boots. Come on. It's an even number. Here's the cool part. If it's an even number, as in your degree is even, both end behaviors go in the exact same direction. Okay? So they're both going in the exact same direction. All right? So that means that my end behaviors over here I'm going to write that a little different. That is looking messy. As x goes to negative infinity, y, and as x goes to positive infinity, y. And I just realized I have a column missing in here, so I'm just going to kind of squeeze it in. Okay? And that's the lead coefficient, because that lead coefficient makes a huge difference. All right? What is the lead coefficient? Yeah, it's a 3, okay? It's a positive 3. So it's a positive, guess what? That means both ends go up, because positive is up. So they're both going to positive infinity, okay? We'll get back to the roots and terms in a minute. I want to go through and do the degree, even, odd, and the end behavior for all 4 of them, okay? So now let's look at the next one. You can graph it on your calculator. Y equals 5x cubed. Okay, so if you don't know how to get to that on the calculator, you can punch the little button that has that little upside down V shape on it. We call it a chevron. Some people call it a hat. I don't know why it's a hat, but you know, that works. This is a cubic, right? We already know that because the degree is 3. Now, is 3 an even number or an odd number? It's odd, okay? Well, if evens go in the same direction, what do you think odds are going to do? They go in the opposite direction. So, a cubic actually looks like your third graph. That is an example graph of a cubic. It's going to go up and down, opposite directions. Now, if the lead coefficient is positive, is it positive in our case? It is. Then the positive side is always the one that goes up. Okay? So that means as x goes to negative infinity, y goes down. As x goes to positive infinity, y goes up. So notice I have my opposite directions. On the negative side, it's going negative. On the positive side, it's going positive. So my cubic, let's come over and kind of label these. This is an example of an x squared. This one's an example of an x cubed. All right? So we can kind of see our graph to our table. All right? Okay, so we have opposite directions. Same direction, opposite direction. All right, so let's predict. Let's see if we can figure this out. Don't punch it in the calculator yet. Okay? Hold on. Just wait. What's the degree? 4. Okay? So 4 is a quartic. Is 4 even or is it odd? It's even, okay? Even means it should be in the same direction, right? They're both going to be pointing up or they're both going to be pointing down. Now, what's the lead coefficient? Negative, okay? So negative is which way? Is it up or down? It's down. So now, plug it in into y equals, you'll see, as x goes to negative infinity, what does y do? Negative infinity, okay? As x goes to positive infinity, y goes to also negative infinity because they both go down. So which of these pictures would be an x to the 4th? Yep. Now, it's not a plain old x to the 4th, right? It had an x third, x cubed, x, and other terms in the equation to get that graph. All right, but it is an x to the 4th. It is a quartic function. All right, let's look at the last one. See if you can predict it without using the calculator, okay? So, first thing, the degree is 5. 5 is what? Even or odd? Odd. Odd means they're going to go opposite. Odd is opposite, even is same, okay? So odd is opposite. What's the lead coefficient? Negative. Opposite means On the positive side, instead of going up where we think it should go, it's going to go down. Okay? So, as x goes to negative infinity, it actually goes up. And as x goes to positive infinity, it actually goes down. So it goes up on the left side of the graph and down on the right side of the graph. Okay, so our bottom graph is an example of an x to the fifth. Okay? Or a quintic equation, quintic polynomial. Now let's look at the roots. Okay, so these are shortcuts, right? So when they ask you to find the roots or to solve the equation, you'll know, did I get all the answers? Okay, so here's the cool part. The number of roots is equal to possible. There may be duplicates, right? The number of possible roots is equal to the degree. Okay, so for a quadratic, degree is 2. Number of roots is 2. Cubic, degree is 3. Number of roots possible is 3. It's that easy. Quartic, number of roots, degree is 4. Quintic, degree is 5. Number of roots is 5. Okay? Super easy. All right, for the next one, you got to kind of think a little bit. But that's okay, you can handle it because it's not that hard. I have a square, right? That's my quadratic. How many turns are there in that curve? 1, right? So I have 2 possible roots. That means I have 1 possible turn. For my cubic, how many turns are there? Well, if I'm driving it like the road, I got to turn around one curve, turn around the other, so there's 2. Are we seeing a trend here? You should, right? It's a 4th degree. 4th degree, how many turns are there? 1, 2. That's not a 4th degree. I put something different up there. I should correct that. I think I put like a 6th degree up there. That's a 4th degree. Okay, so how many turns are there? It is 3. Okay, so I take the number of roots, or I take the degree, and subtract 1, and that's how many terms I should have in the graph. Okay, so if 5 is the degree, 4 is the number of turns. Now you may say, Mrs. Booth, this is all cool, and that's fine. Remember, these are common sense rules, right? This is to help me. So we're going to look at 3 examples. I'm going to do a logic diagram for you, and then we'll look at 3 examples of how we can use this information where I give you an equation or a graph, and you can predict basically what the other one's going to look like. And it's really kind of cool because then you're less likely to make mistakes later on. Hello, this is Mrs. Boots, and we're going to do a logic diagram for our end behavior. So if you really liked the logic diagrams in geometry, this is an example of how you can do one with a decision-making process in Algebra 2. It's kind of fun. You don't have to do this on any problems. I just thought that you might want to see it, okay? So, and it's even in your notes. You can fill it out. So I remember our first question from our notes was, what is the degree? So we would look at the number and we would determine, is it even or is it odd? Remember that? Is it even or is it odd? And if the degree is even, then we know they both are in the same direction. And when I'm talking about both, I'm talking about the end behaviors. The arrows go in the same direction, okay? If the degree is odd, then both arrows don't go in the same direction, right? They go in the opposite direction. So odd is opposite. Once we figured out if they were both going in the same direction or the opposite direction from our degree, we look at what is the sign of the lead coefficient, right? So our lead coefficient could be positive or negative. There's the only 2 options, because if it's 0, the term doesn't exist and you go to the next term, okay? So if it's positive and they're both going the same direction, they both go up, right? If it's negative in the same direction, they both go down. Now the opposite direction ones are a little tricky, right? So if it's positive, then the x infinity goes up. So the right side, maybe you put that in there. Okay, so the right side goes up. If it's negative, the right side goes down. Okay, and because it's opposite direction, if the right side's going up, what's the left side doing? Yeah, the left side's going down. And if the right side's going down, then the left side's going up. Okay, so our opposite direction tells us, and that's all the logic diagram is. If I ask these questions, it will tell me what the function looks like. So let's go ahead and do some examples in our next video. And now let's do some in behavior examples so that we make sure that we understand how to use the information we just covered in the notes. All right, so we're doing the exact same thing. Example 1, is it even or is it odd? Well, I look at the degree. The degree is 2. 2 is an even number. The next question is the sign of the leading coefficient. What's the leading coefficient? It's a positive 1, so my sign is a positive. Now the number of roots. The number of roots is the same as the degree. The number of turns is always the number of roots minus 1. Or it's the degree minus 1 in this case. So my in behavior, if it's positive and it's even means they both go the same direction. Positive is up. So it's x goes to infinity. We put a negative in there because we always do left side first. As x goes to negative infinity, y goes to positive infinity. As x goes to positive infinity, y goes to positive infinity. Both going positive infinities on the y, both going up. Okay, example 2, same thing. What is my degree? Degree is 8. Is 8 even or odd? It's even. That also tells me my number of roots is 8. And my number of turns is 1 minus the roots, which is 7. All right? So now let's look at the leading coefficient. The leading coefficient is a negative 5, so it's negative. Negative means opposite directions. One's up, one's down. Okay? Is it? No, that's odd. Almost tricked you there. Nope. Even, they both have to go the same direction. But it's negative. Oh yeah, that means they both go down, right? Both go down, okay? So x goes to negative infinity. I'm getting ahead of myself here. Y goes to negative infinity because it's going down. As x goes to positive infinity, y goes to negative infinity. Both going down because it's an even and it's negative. Okay? Let's look at the last example. Not the last one, the last big one. Okay? Example 3. What's my degree? Degree is 13. Very good. 13, is that even or odd? It's odd. Okay? So it's odd. We can already see the leading coefficient is negative. How many roots am I going to have? The same as the degree. How many possible terms am I going to have? Minus 1. Degree minus 1, 12. Okay, in behavior, if it's odd, odd is opposite, and it's negative. So that means the positive side is going to go negative. So on the positive side, y is going to negative infinity. But it's opposite, so that means on the negative side, y has to do the opposite of negative infinity, which would be positive infinity. please notice that your x negative infinity, x positive infinity, that part doesn't change, right? We always look at the left side of the graph, look at the right side of the graph. What's changing is the y's. Am I going up or am I going down? Every single time. Okay, now we're going to take a description and we're going to work backwards. Okay, so remember I told you that we could describe a graph and figure out what it basically looks like. It has 6 terms. Okay, remember the number of terms is the degree minus 1. So if I know I have 6 terms, what's my degree? Yeah, my degree is 7. Okay, so I know my degree is a 7. So I know I have an x to the 7th power. All right, and it faces down. So down means the positive side's going down. In order for it to be for the positive to go down, I have to put a negative in front. This is the simplest possible answer. Now, yes, I could have written 6 to the x plus 6 to the 5th plus 6 to the x plus 6 to the x cubed, x squared, x, blah, 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 blah. You don't need any of that. We just want the very simplest one. Okay, example 5 is quintic. All right, quintic. What's a quintic? Now we got to go back to previous lesson. Quintic was degree of 5. So I know this is an x to the 5th because quintic means 5. And it says up, so that leading coefficient is positive. I don't even have to put a number there. There's my quintic. Kind of cool, huh? So I already know what it should look like, right? It should have opposites, and on the positive x side it's going to go up, and on the negative x side it's going to go down. And there's going to be possibly 4 terms in between and 5 possible roots. Just because we know some basic information, we know what our graph's going to look like. Okay? Now, we have 8 roots. What's that tell us? That tells us the degree. That's awesome. So that's x to the 8th. Now, what's the end behaviors doing? Because that's what they gave me. It's going up and up. They're both going up, which means it's a positive in front. All right? And this concludes the examples for the end behavior. Please go ahead and get started on the practice problem.